So why is relativity not good enough? Let's face the facts. The trouble with contemporary physics parades in empty concepts, seemingly unfathomable observations, and superficially miraculous coincidences. Most notably, dark matter and dark energy are without correspondence to reality. They're only needed for the current cosmological model to tally with data. Moreover, nearly homogeneous temperature and uniform distribution of matter across the horizon, as well as its unexpected anisotropies, including the cold spot, as well as the excess of matter over antimatter, seem unfathomable observations only from the prevailing perspective. Also, the fact that the vacuum density is exactly critical, and that inertial and gravitational masses are exactly equal, and that the age of the universe is inverse of the Hubble parameter, seem miraculous coincidences only from the predominant paradigm. It is not only contemporary cosmology, but also elementary particle physics is in trouble. The key concepts of quantum mechanics, superposition, entanglement, and action at a distance are not real things, but instrumental concepts needed for the models to tally with data. Moreover, why matter comes in 3 generations, why baryons comprise exclusively of either matter or antimatter, but never mix, why the strong force does not violate charge parity symmetry, and why the proton spin is not a simple sum of its component spins, are examples of questions that are puzzling only from the perspective provided by the standard model of particle physics. More fundamentally, modern physics is in trouble without a comprehensive and consistent understanding of the essence of time, space, and matter. While all these shortcomings of modern physics have been recognized, still it is not acknowledged that there is hardly any point in attempts to amalgamate general relativity and quantum mechanics, for nature displays rules and regularity far beyond modern physics. Namely, as remarkable as it is, the data look all the same irrespective of what we look at. Copious logarithmic spirals, numerous networks, and branching patterns are familiar to you, as well as data sets that closely comply with power laws, that is, mostly follow straight lines on log-log plots, including distribution of craters on the moon, distribution of galaxies, spectrum of cosmic rays, Tully-Fisher relation, and the M-sigma relation, and other astronomical data sets. The power law, also known as the allometric law, is in fact an approximation of sigmoidal curve, which in turn is a cumulative curve of the skewed distribution with long tails, such as Planck's law of radiation, Maxwell-Boltzmann distribution, stock price fluctuations, sizes of companies, income distributions, you name it. The universality of these patterns, reflected or referred to as the grand regularity, implies a truly universal law of nature, and hence a theoretical unity that lies well beyond modern physics. Since we are dealing with data of many body systems, it seems logical to look for a statistical theory to explain this grand regularity, including the astronomical observations. Before introducing you to this general law of nature, I wish to emphasize the difference between a model, in other words, an effective theory, and a true theory. To be explicit, a model mimics data, whereas a theory explains the phenomenon in agreement with data, or if it doesn't, then phenomenon remains unexplained and the theory is no good. This is to say, a model can be modified, whereas a theory cannot, because any fix or tweak would in fact mean falsification. From this perspective, the need for dark energy and dark matter proves general relativity false. Its founding axioms must be wrong. Now, to account for the grand regularity that we witnessed across the scales and disciplines in power laws, skewed distributions, and sigmoid curves, we need a universal axiom, certainly more comprehensive basis than the postulates of relativity. I find the ancient atomistic axiom fruitful. It claims that everything is ultimately comprised of undividable fundamental elements. Throughout the ages, the question has only been what the fundamental element is. In the mid-1920s, Gilbert Newton Lewis put forward a new Isaac Newton's hint that the particle of light could be the fundamental element of everything. This American chemist coined the word photon. He had a good reason to consider the wavelength of light as the primary ingredient. Namely, the massless photon does not decay, and the spectrum of light reveals an invariant entity, Planck's constant, that appears in numerous contexts. Thus, I assume that everything consists of photons and inspect things and phenomena from this perspective. The wavelength of light carries energy on its period as well as momentum on its wavelength. Planck's constant expresses these complementary properties of the photons so that the energy of the photon decreases as long as its period increases and vice versa. So let us proceed to see what we can understand from this perspective. In this conference, the foremost question is, what makes up the vacuum? It's a common knowledge that two photons, when out of phase, cancel each other. However, the photons themselves do not vanish for nothingness, but continue in propagation. We cannot see these paired photons, nevertheless, they carry energy and time, and therefore cause phenomena known as gravitational and inertial effects. In this fabric of space, in this fabric of space, we only see the unpaired photons within these numerous fibers of invisible paired photons. The spectrum of space, that is, the photon distribution given by the Planck's law, reveals that the void is not without structure, but in fact highly structured in strings of paired photons according to the renowned Bose-Einstein statistics. The structure of vacuum as a strings of paired photons explains why it takes two turns rather than only one for a spin half particle to return to the original state. The second turn unwinds the twist that the first one introduced. So let us see how this YouTube video demonstrates this idea. So now you look at carefully these lines, how they need two revolutions to. Oh, sorry, it didn't show up. Oh, okay. Okay. Yeah. Okay. Thanks a lot. Okay. The particle is at the middle, and these are the strings of the photons that I was talking about. And when you watch it, you see that it takes two revolutions for the particle to return to the initial position so that these lines are unwind. Very well. The destructive interference of photons is familiar phenomenon, for example, from the double-slit experiment, which we now, knowing the structure of the vacuum, can understand lucidly. So now that we know the structure of the vacuum, it's easy for us to understand that once the electron goes through one of the slits, along its passage, the electron has generated waves of the vacuum that also go through the other slit, and hence these waves interfere with the electron before it hits the detector. In this way, the paired photon vacuum explains the interference pattern understandably. There is no need to think that the electron would have gone miraculously through the two slits simultaneously. Let us also reconsider the interpretation of the action at a distance that supposedly displays non-locality. In an event, there in the center, two photons with reversed faces set off in the opposite directions. When the face of one of the photons is detected, then the face of the other one is known instantaneously because it is just reversed. Nothing spooky about it. The photon phase is recorded by a two-channel detector. It's like doorways in a corner. When you face the corner at 45-degree angle, you see both doorways of about 70% of the opening. That is in total 140%. Whereas when you face the corner at 90-degree angle, you see 100% of one of the doorways and none of the other. Thus, when you rotate one detector relative to the other, the correlation varies as cosine because the detection amplitude varies between 100% and 140% as a cosine. So there is no evidence of the spooky action at a distance. The mainstream idea that the electron is a quantum field rather than a solid particle seems contrived when the double-slit experiment is interpreted so that the wave function is a model of the vacuum quanta rather than a model of the electron. So, how does the electron actually look like? I follow the understanding of Arthur Compton and Alfred Parsons since 1910s, as well as that comprehension of André-Marie Ampère since 1820s. These scientists considered that the electron is a torus, like this. And more recently also David Heston has proposed the same idea that the photons along a toroidal path make up the electron. This makes perfect sense when you understand that the dimensionless coupling constant, known as the fine structure constant, is a ratio of two actions. The electron action is obtained from the familiar Gauss law as the energy of the Coulomb field and compared to the most elementary action, the quantum of action, denoted by Planck's constant. The numerical value of the fine structure constant, essentially the curved length of the torus, reveals that 138 quanta of light make up the electron. Now that we know the structure of the electron, it is possible to understand in tangible terms the gravitational and electromagnetic fields. The gravitational field is the distortion of the electron about the electron caused in the surrounding vacuum. The coupling between the electron and the void gives mass to the electron. It is small, technically speaking, because the geodesic curvature of the torus is small, so that the loop here pretty much cancels the effect of the loop on the other side. And hence, the mass of the electron is very small. The electromagnetic field, in turn, is the distortion that the electron causes in the surrounding vacuum by tearing apart these pairs of photons to visible trains of photons. When you see the torus structure of the electron and the number 138 for the first time, as probably you might be doing now, you might be baffled. However, isn't it much more puzzling if the electron were, on the one hand, a quantum field that extends to the ends of the universe, and on the other hand, a point-like particle? However, what I'm saying is not at odds with observations. Namely, the electron is a composite particle because it breaks apart. Moreover, the electron's presumed point-like character is based on the assumption that the experimentalists state very clearly in their paper. If the electron is a composite particle, its constituents are strongly bound, giving the electron the observed point-like quality at experimentally accessible energies. Indeed, electron constituents, the quanta of light, when in their tight coil, are like the quarks that are also strongly bound with one another. Now that we know the electron structure, we also know the structure of the positron. It's just a mirror image of the electron. The electron-positron annihilation, in turn, is a reaction where the two torus unwind to the fibers of paired quanta that make the vacuum. Also, the two readily detectable photons emerge from the annihilation as the vacuum balances the disappearance of the two charges. Moreover, the structures of the proton and the neutron are at hand because quarks are arcs of the electron torus and the positron torus. The down quark is 1/3 of the electron, and the up quark is 2/3 of the positrons, as their charges imply. The quarks link to each other by the gluons, which are in fact short wavelength photons at the interfaces of the quarks. These structures of the proton and the neutron follow unambiguously from the fine structure constant. They could not be assembled in any other way. Most importantly, these wireframe models produce electric charge, magnetic moment, and mass of the proton and the neutron in agreement with measurements. The structures of other elementary particles can be constructed likewise in agreement with measurements. Now that we know the structures, we can comprehend their reactions. Electron capture, for example in a star, can be understood so that it's a reaction where an electron next to a proton, here on left, loses one quantum, that is a neutrino, and thereby becomes W boson. It opens up, and subsequently 2/3 of the W boson is annihilated with the proton's up quark to a train of paired quanta, and leaving behind 1/3, which becomes the down quark of the neutron. Indeed, elementary particle physics is elementary. With this insight to the vacuum and elementary particles and their reactions, we can understand gravity so that bodies couple to the vacuum and move together with a moving vacuum. A distant galaxy is receding from us because the void between us and the distant galaxy is expanding from the quanta that are released from matter to the void from numerous reactions all over the universe. Conversely, a nearby galaxy, most notably Andromeda, is approaching us because more quanta between us and Andromeda are flowing out to the greater universe than are coming into this relatively small realm. The efflux and influx of the quanta balance first at about the distance of 4 million light years, where the Hubble flow commences. In other words, objects fall not because bodies attract each other, but because bodies move along the vacuum that is on its way toward balance where the curvature is least. For the same reason, celestial bodies tend to be round. Motions take along the steepest gradients, that is, along the least time paths known as geodesics. Therefore, bodies fall straight down and the universe expands in every direction. What I'm saying now is not new, since already Bernard Riemann thought in 1853 that gravitational field is a fluid whose sources and sinks are bodies. Also, Ivan Yarkovsky suggested in 1888 that the ether converts into matter when being absorbed in the celestial body. It's only new now to know the structures and reactions of the vacuum and particles, and thereby to know how the old reasoning makes sense in concrete terms. By the same token, we can understand inertial effects. When you slam on the brakes, you keep moving because you are coupled to the vacuum. When you step on the gas, you resist the change because you are coupled to the vacuum. For the same reason, when you hurl a stone with a sling, the stone, while in the sling, keeps changing its position relative to the rest of the universe, that is to say, its gravitational field embodied in this quanta of vacuum. This curvilinear motion is the imbalance that is experienced as an inertial force. For the same reason, a top spins upright, the rotating Earth is flattened, and the satellite galaxies orbit in their central galaxy in the same plane, such as Magellan clouds orbit the Milky Way. Indeed, the vacuum drives everything towards balance. Undoubtedly, we can calculate numbers that agree with data using virtual photons, virtual particles, wave functions, pseudo-forces, curved space-time, etc. But this instrumentalism does not explain to us even why an apple falls down. Let us be honest. Modern physics has abandoned the guiding principle of modern science, liberating mankind from the medieval magical hermetic tradition and opening reality to be comprehensible by everyone. As David Merlin put it, the fashionable shut up and calculate attitude is intellectual dishonesty. Now, with the obtained insight to the gravitational and inertial effects, as well as to the expansion of the universe, we should derive the general equation of motion for the quanta as it is needed for quantitative analysis. Since everything is made of quanta, everything can be presented in terms of an energy level diagram of quanta. Consider in the diagram each loop as a quantum, the elemental form of matter. Moreover, consider each wavelet as a quantum, the elemental form of radiation, that is to say, a photon. For example, you can imagine that a molecule is a compound of atoms, which are ultimately compounds of quanta. The molecule emerges from reactions of its material substrates, including the quanta that are absorbed or released in the reactions. Since everything is ultimately comprised of quanta, any transformation, may it be a nuclear or chemical reaction or a change in position, can be described in the same way. Next, let us transcribe this energy level diagram into an equation of state and then convert the changes of state into an equation of motion. To this end, we employ statistical mechanics. We may choose any given entity, index it with J, and write down its probability for it to exist. The probability is a product of its constituent entities indexed with K, because in this way the probability would be 0 if any constituent was missing altogether. Moreover, the smaller the energy difference between the product and its ingredient, the less external energy from radiation is needed to drive the reaction from substrates to the products. That is, across this energy gap between the initial state and the final state. Next, for a population of indistinguishable entities, the probability is simply the product of individual probabilities divided by the number of permutations that are inconsequential. Finally, for the probability of a system of populations of various entities, the total probability is the product of population probabilities. If any one of these populations were missing altogether, the system would obviously not be the same. That's the basic idea. I like to emphasize this is the main result. What follows now is merely mathematical manipulation. It will not change a thing, for we respect the equality sign. This is to say, we will not add any parameter or any factor. The equation of state is obtained by taking a logarithm of probability to give the entropy. The equation of state in turn can be transformed into an equation of change simply by taking the time derivative of the entropy. The change denotes flows of quanta. The quanta move so that energy differences of any kind will level off in the least time. The equation of evolution says that entropy increases invariably when the free energy decreases. Ultimately, the free energy is consumed altogether, and then entropy is at maximum. Then the system is at a state of balance. This equation of change can, or evolution if you like, can be analyzed to show that it describes the universal patterns, that is to say, grand regularity. We can interpret astronomical data using the equation of change when expressed by continuous potentials. So we make this kind of approximation that we abandon this discrete presentation for these convenient continuous potential. You can recognize this equation in a state of balance where dissipation, the last term, vanishes, that it's the familiar virial theory. Note, when a body moves from the hilltop down to the valley bottom, also the landscape changes because the body is part of the landscape, the whole universe. Since everything depends on everything else, the evolutionary path cannot be calculated exactly, despite the fact that they all follow the least time law. Only trends of these historical processes can be outlined. Let us begin by questioning the dark energy. Its existence has been inferred from the type 1 supernovae data that does not follow a straight line on a log-log plot, but curves away the further we look toward the beginning of the cosmos. However, when we follow the least time path of the light from an exploded star, we understand that its color shifts red because the stellar remnant is moving away from us and because the universe is while the light is on its way to us. This latter factor, the gravitational redshift, due to the expansion, is omitted from the standard cosmological model. When we acknowledge that the gravity of the universe is diminishing as the universe is expanding, there is no room and hence no need for dark energy. Let us continue by questioning dark matter. Its existence has been inferred from the velocity dispersion and the rotation of galaxies. Once again, when we acknowledge the decreasing gravity of the expanding universe, we understand that a galaxy is moving and rotating in this gravitational field that extends from the sparse present toward the dense past. Therefore, there is a feeble field from the very beginning of the universe to the present time. And this feeble field causes a tiny acceleration equivalent to the speed of light per the age of the universe. The universal acceleration is everywhere, but you see it only at the galactic scale, where the acceleration vanishes far away from the galaxy center. The same feeble force drives Andromeda towards us with a speed of about 300 kilometers per second. Then the bending of light, when calculated by this principle of least time that I'm advocating, does not leave room for dark matter either. This conclusion, of course, questions the measurement or calculation of bending and time delay of light that is tangent to the sun. Indeed, The principle of least time delivers with one and the same formula the correct value for the gravitational bending, delay, and precession, whereas general relativity uses 3 different formulas for one and the same phenomenon. Specifically, Eddington and others later omitted parallax in the measurement. Consequently, too small value has been deduced for the bending. The mistake is easy to understand. When you view your fingertip with your right eye and then with the left eye, you can see how it moves relative to the background. So, in order to compare the same ray from the night sky and that detected during the solar eclipse, one needs to adjust the telescope about 1,000 kilometers. But Eddington did not take that into account. Therefore, the bending was measured smaller than it actually was. I should mention, among other results, that the least time principle also delivers correctly the values for mercury perihelion precession and the gravity probe B experiments. I have carried out far more extensive research than just presented now to find out the limits of this atomistic axiom, but so far I haven't found the limits. To be explicit, I'm not aware that the photon could break apart or emerge from nothing. I'm not aware of anything that is not made of photons, and I'm not aware of any process where the flows of quanta would not level off energy differences in the least time. However, I do acknowledge that there is no data without some interpretation. I'm biased, like everyone else, to see the things the way I do. All I'm saying is that this atomistic tenet fulfills the criteria of accuracy, consistency, scope, simplicity, and fruitfulness that Thomas Kuhn required of a valid scientific theory. Let us now return to discuss the problems of modern physics. Clearly, these are problems of physics because nature is unproblematic. We need to revise our thinking. I propose that we abandon instrumentalism for realism. Let us no longer model data and interpret our models as images of reality, because those images include dark energy, dark matter, wormholes, multiverses, action at a distance, superposition, entanglement, etc. Instead, let us assume that everything is made of quanta of light, and let us see what can be understood and explained in this way. To explain the uniformity across the horizon does not need an ad hoc inflation theory. Instead, it follows from the least time quest for balance. Namely, the greater the energy difference, the faster it decreases. For example, the brightest stars shine the shortest time, and therefore, eventually, there are only minor energy differences as we witness. For the same reason, the little variation in the cosmic microwave background radiation is not truly random, but we see anisotropies. They result from historical processes where the greatest forces are consumed fastest. Think about a practical example that you are supposed to cut a cake in pieces that in the shortest time so that the pieces would be of equal size, or approximately at least. First you would halve the cake, then halve the halves, and so on and so on. So you realize that this process of decreasing energy differences in the least time is not a function of the initial state, but depends on all the previous stages, and that's why it cannot be predicted right from the outcome, from the start. By the same token, we understand that the matter is a standard of substance. We have other standards that we are well familiar with. We tend to shake hands with the right hand. We tend to drive on the right hand side of the street. Of course, there are notable exceptions. And for the same reason, we realized that matter, if it wasn't excess over antimatter, we would not have powerful mechanisms such as stars that convert quanta in energy-dense matter into the sparse space. From this perspective, stars, galaxies are there because they break down matter into the vacuum. For this very reason, the baryons are not mixtures of matter and antimatter. And now that we know the structure of the particles, we realize that the gluon is just a short wavelength photon, and hence the charge parity symmetry is not broken. Likewise, we understand that proton spin is more than its constituent spins in the same way as a molecule is more than its constituent atoms. Moreover, vacuum density could not be other than critical when space emerges from matter. Inertial and gravitational mass could not be different from each other because mass is a measure of how strongly matter couples to the surrounding vacuum, which causes both inertial and gravitational effects. The age of the universe could not be other than the inverse of the Hubble parameter because time and energy are complementary qualities of the photon. As energy decreases in expansion, the time necessary increases at the same rate. These and other conclusions are detailed in my papers, all available at my homepage. In this last slide, I just listed up a few for an example. Thank you for your attention.
Okay, we have time for a few questions.
We know that from the electromagnetic radiation, if we have enough frequency, so for instance, if we have photons with length weight minus 50 meters or frequency 23 hertz, so we can produce real matter, so protons, for instance, or protons and antiprotons, when we stop the photons. Mm-hmm. So in fact, what the wavelength or what the energy of photons in your presentation you mean? So it is very great diapason. So it is from the 10 to minus 15 length, where we can produce a real matter, or on the other side it could be kilohertz, or it could be we used it in the radios sometimes. Yes. That you can have kilohertz, or you can have 100 meters photons. And don't you think that maybe the neutrinos would be the basic, because it looks like that it is somewhere where the lowest wavelength or frequencies of photons is there is finding a neutrino, for instance, in beta decay. This is not enough energy to produce a photon in our cognition, so we see neutrinos, and I think maybe the neutrinos would be there. So that's it. Yeah. Thank you.
So let me rephrase your question as I understood it. You are basically asking what is the wavelength of these structures that I'm presenting. I am not questioning experimental results in this respect. That is to say, whatever the estimates that we have for the size of the proton, I have no reason to question them. They are indeed small particles, and they are therefore of high energy. I'm just showing how they are made of photons, of very short wavelength.
Thank you for very inspiring presentation. I really enjoyed it, but I have some, question. For example, related. You were saying that the electrons, if it moves, it's not the wave function object, but it's the wave which are generated by the movement of electron in the vacuum, right? But how about the, so to speak, you mentioned this double slit experiment, when there is some kind of information about the which way, right, then this wave patterns collapses. Is that possible to explain in your model? And the second thing, you were also questioning the entanglement, but to my opinion, there is this Bell's inequalities, which shows that it looks like the hidden variables, right? So, because if you say that the photon phase is opposite, that's the hidden variable, right? I think we have ruled that out with the Bell kind of experiment, right? Can you comment on that?
Yes, I start on this latter question. In quantum mechanics, we tend to think that the phase does not exist before it is measured, right? The situation is completely analogous if you have your watch without any numbers or reference direction. It doesn't point any time. So we always need a reference phase to say what the phase is. However, irrespective of the reference, we know from the beginning that the phases of the two photons are opposite. Although we haven't used a device to determine what the phase is. So I think that this is completely a conceptual problem that we have created ourselves because we have not been able to figure out the cosine curve. We have thought it's a linear dependence, which is elementary mistake in understanding experimental results. Then for the double slit experiment. I explained that to myself first so that I rely on this holistic understanding. I assume that every phenomenon is understood likewise. So I consider that the boat is coming into harbor where there are two openings. The boat goes through one of the openings and the waves that it generates also go through the other opening and rock the boat when it comes to the pier. What you're saying about this detecting or knowing which way the electron went. Of course, we have here experimental studies on this matter, and it is known nowadays that you can determine the passage of the electron provided that you detect this interference pattern close to the detector. Whereas if you attempt to detect the electron at the slit, you fail because the detection itself causes ripples in the vacuum and destruct these interference patterns. And this Sarif Asfar did these famous experiments where he showed these flaws of quantum mechanics. And I should also mention that there's a YouTube video by Fiegel. Fiegel is his name. I can't get the right first name now. It's really remarkable amateur physics that has shown inconsistencies in this quantum mechanics when it comes to double slit experiments. Of course, we also have data that when there are three slits, the theory does not exactly produce what we observe. So there are, to my opinion, good reasons to doubt that the way we understand double slit experiments, when we understand that there's also the vacuum, the problem goes away.
So you didn't do any statement about the special theory of relativity. How does it match with your model? Is it true or false or inconclusive?
I would be inclined to take the stance that was also already here, that mathematics, it may be general relativity or other theory, is a model of reality. I'm not particularly interested in overturning general relativity because for me it's only a model with its deficiencies that were presented here. I'm not against general relativity. I think it's a great model, but it doesn't explain to us what's going on.
No, but the question was a special theory, not the general theory.
Okay, special theory, it is about the vacuum as if there were no matter at all. So straight lines makes great sense to me, but we don't live in that kind of world.
That's a big question about the entropy.
Yes.
Entropy all the time increasing, right?
That's right, no exception, absolutely no whatsoever.
There is no any contradiction conflicting with your theory. This structurally actually should be reduction of entropy.
Yes, that's the doctrine that you tend to promote, that entropy would mean disorder. I say it's not. The disorder is no cause of anything. It's a consequence.
Okay, we need to wrap it up and go to break so we can stay on schedule.